Okay, for 8.2, we are going to start multiplying and factoring. And one of the reasons that Chapter 7 was so big in knowing the rules of exponents is because you're going to need them to be able to multiply properly. So this has an example of distributing, which we will get into later down here. So let's take a look at this first part 1, multiplying a monomial like negative x to the third with a trinomial like this one that's right here in this problem, and it's even a multiple choice question. So let's distribute. Negative times 9, that's a negative hidden invisible 1 times 9 would be negative 9. Let's review that when you multiply x to the third times x to the fourth, if you're multiplying variables with the same base, their exponents get added. That's why you guys have already taken a chapter or a chapter test on what to do with exponents. When you multiply them, they get added. So this is x to the 7th. Then you have negative x times negative 2x to the third. Negative 1 times negative 2 would be positive 2. And when you add x to the third and x to the third, you get x to the 6th. And then last, negative 1 times positive 7 is negative 7. And x to the third and nothing is just going to be the x to the third that you carry over with it. So the final correct answer should be negative 9 x to the 7th, which several of these are, but not b, plus 2x to the 6th, which is only d. So let's double check that the rest is correct. Minus 7x to the third, yes. Okay, so D is the answer there. So let's take a look at number 2 and try it. It's not multiple choice, so we're going to have to work it out without having multiple choice here. 5 times 3 is 15. N times n to the third would be n to the fourth. Remember, there's a hidden invisible 1 here, and they get added. 5 times negative is negative 5. That's a negative 1 hidden. N times n squared is n to the third. 5 times 8 is positive 40, so plus 40. N just is by itself, so it's just n. All right, this is a good time to push pause and you try this one. All right, I hope you tried it on your own because I'm going to fly through it super quick. 6 times 2 is 12. X times x cubed is x to the fourth plus 42 x squared, because there's a 1 there and a 1 here, which makes it x squared. Okay, to find the greatest common factor, the GCF, that means what number can be multiplied to get 5 and 25 and 45. What is the common factor? Sorry, I said multiplied, but really I mean what number can you divide out of all three of those terms? So the number that can divide out evenly of 5, 25, and 45 is just 5. 5 divided by 5 would be 1, 25 divided by 5 would be 5, and 45 divided by 5 would be 9. So each of these divide evenly by 5, so 5 is one of the GCFs, but also you can pull out x's. You can pull out however the greatest number, many of x's there are, out of each term. So I see 3 in this one. That's why they've written those 3 out. I see 2 in this one, so they've written those 2 out. And I only see 1 in this one, unfortunately. So if there's only 1 in any of them, then 1 is the greatest amount you can pull out, because you can't pull 3 out of all of them, because this one only has 2 and this one only has 1. So the greatest number of x's that we can pull out is just 1, because that's the greatest amount that's in this particular term. So pull out 5 and x, so the greatest common factor is 5x. So what is the greatest common factor of 3x to the fourth minus 9x squared minus 12x? Each of these numbers divides evenly by 3, so you can pull a 3 out of each term. And you can pull an x, but you can't pull 4 x's when this one only has 2. And you can't pull 2 x's, even though both of these could, when this one only has 1. So the greatest number of x's you can pull out is just the 1. So the greatest common factor of this trinomial is 3x. All right, what about number 2, 4a to the fourth and plus 6a squared? The greatest number that you can divide both 4 and 6 evenly by is 2. And the greatest number of a's we can pull out would just be 2, because you could pull 2 out of this one and 2 out of this one, but you can only pull 4 out of this one and you can't pull 4 out of this one. So a squared, because you can pull 2 squared ones out. Okay, we're going to get into how to do this stuff on the next page, but this is just an extra area for you to see how they factored, which is basically pulling the greatest common factor out of a trinomial, and I'm going to show you how to do that on the next page. So turn it over, and again, if you need more practice, refer back to that previous page, but I'm going to tell you how to do it by working out this number 1 problem. So first, what is the greatest common factor of 9x to the 6th plus 15x to the 4th plus 12x squared? I hope right away you know that these can all 3 be divided by 3. So I'm going to pull a 3 out. I can also pull some x's out. The greatest number of x's I can pull out would be 2. So I'm going to pull out x squared. Now, here's what happens. Please stay with me here. It's like reverse distributing. I want, when I distribute 3x squared times whatever 3 terms are going to be in here, I want it to equal 9x to the 6th plus 15x to the 4th plus 12x squared. So what 3 terms should go inside the parentheses to where when I distribute the first term, I would get 9x to the 6th. So 3 times what is 9? 3. X squared times what would be x to the 6th? Remember, they get added, so there should be 4 of them. So now let's check. If I distributed 3x squared times 3x to the 4th, you should get 9x to the 6th. Okay, let's keep going. I may not have made my parenthesis far enough over. I know it's plus, so I'm going to put a plus. I want 3x squared times whatever this is to equal 15x to the 4th. So 3 times 5 would be 15. I need x to the squared, x to the 2nd to equal x to the 4th. So that's going to be 2 of them. Remember, they get added. I'm going to bring down a plus. I'm running out of room here. 3x squared times what would equal 12x squared? 3 times 4. And x squared to get x squared is just nothing. If you put an x there, that would be 2 plus the 1 here, which would make it 3, and that's not right. So 4 is by itself. Okay, I hope that makes sense. So this is the factored form of this trinomial. So we took a trinomial that has some greatest common factors in it, and we factored out the greatest common factor, and now this is factored form. Okay, so let's do the same thing on this one. 6m squared minus 15m. So what is the greatest common factor that can come out of these 2 terms? They both divide evenly by 3. We could also pull out at least 1m. Let's look. There's 2 there, and there's only 1 here, so we can only pull out 1. So now let's reverse distribute, or factor. It's called factoring. I should stop saying reverse distributing, but that to me is how it makes sense. 3 times what is 6m squared? 3m. That would be 2m, because m times m will give us our m squared. 3 times 2 will give us 6. Okay, put a minus there because it's minus. 3m times what is 15m? Should just be 5. Don't put another m there because that would be 2, and there's not 2 here, there's only 1. All right, there's a couple of them now on a you try, so I'd love for you guys to push pause and try these next 2, factoring it on your own. All right, I'm going to go kind of quick because you probably did it on your own. You can pull out a 4 and an x from this. And once you pull out a 4x, that would leave an x squared inside, a plus 2x, and a plus just 3. Okay? When you go to this one, the biggest thing you can pull out is 5, meaning divide. You could not pull out a k because there is none on this term, so you should not have pulled out and factored out a k. Now instead you should do k to the 3rd is left inside because 5 times k to the 3rd is 5k to the 3rd. 5 times 4k squared would be our 20k squared. And 5 times negative 3 gives us that negative 15. All right, here's the last, and I'm sorry, but probably most important part of today's lesson. That's why it has a little asterisk by it. It's special. Anytime your A term, which means your first term, your leading term, is negative, you have to pull out the negative with it. So see how up here I only pulled out 3x squared, I only pulled out 4x, I only pulled out 3m, I only pulled out 5. That's because each of my very first terms were positive. Those were all positive. If the first term is negative, you have to pull out the negative with it, which is going to change everything on the inside. Let me show you how. What, besides pulling out the negative, can divide evenly between these three terms? I hope you're looking at it saying 6. So we're going to pull out negative 6, and we can take out some x's too. We can pull out, the most we can take is 2. So x squared. When you distribute the rest, negative times positive is going to give us this negative answer. So all three of the terms in here were negative are now going to become positive, because if I distributed it, it would make it negative, which is what we need. So these are all going to be pluses in here now. If you don't believe me, after we get our answer, go back and distribute it and make sure this is the answer it comes out to be. So negative 6x squared times x squared would give us the negative 6x to the 4th. Negative 6x squared and plus 3x, check it, negative 3x squared times, positive 3x is negative 18x to the 3rd, and then 2 by itself would be this. Okay, you have a U try, so push pause, pull out that negative, here's your hint, because it's in the first term. Okay, final answer here, if I pull out a negative 3x, the leftover inside would just be x squared. It would be minus 4x, because negative times negative is what's going to make that a positive up here. And it would also be minus 5, because negative times negative is going to make that positive there too.